Okay, so we know that data is in numbers is always stored in the forms of zeros and ones. Okay, zeros and ones, and we now know that they can be saved for a short time. Okay, and we also know, though, that we have in the back of our mind that big numbers have to be stored someplace, okay? And so does language, okay? Alphanumeric information. Data, in other words, has to be stored, okay? So if you're using a calculator, for example, what are you doing? Two ways to use a calculator. If you're using a Texas Instrument calculator, then basically what you're doing is you're keying in a big number, some kind of a number. You're pushing the numbers down, okay? And then the next operation is to put an operator. Are you going to add? Are you going to add to it? Are you going to divide? Are you going to take square root of something? Okay. Are you going to have a combination of things? Okay. So the number itself has to be temporarily stored. Okay, it's stored in something that we call a register. Okay, so we store that first number that we put in a register. Same thing can be said if we were talking to a computer or whatever, or giving it language. That language has to be stored, and it's stored in a specific register. Okay, so there are certain registers that are used for language and certain registers that are used for numeric. Okay, and we normally arrange our electronic system to tell us this range of registers are for this other range of registers are for this other thing, okay? And then all we have to do is we can switch registers around, or the information can flip from register from one, we can exchange it from one register to another and so forth. We can add what's in one register to what's in a second register itself, and you get an addition to put into a third register, all right? We can do all those things, but what we are talking about is registers. All right? Memory registers then are your memory storage units. Okay, so memory storage units. Then the question becomes how do you get the numbers in, or the values into those individual memory storage units? Because each storage, okay, consists of a string of bits. Okay, a long, very long string of bits. It can be a byte long, and it can be several bytes long to make a word. Okay, and it can be a much longer. That is essentially for long numbers. All right. So those are called registers anyway, and we have to we have to place the numbers, the value, the data into those registers. We do that by using what we call shift registers. So we actually sequentially move the data one bit at a time into these shift registers. So it's a way of us filling up those registers with numbers. Now, if you're using, instead of a Texas Instruments calculator, if you're using an HP calculator, okay, you actually, what you do first is store all your data first. You store your data, and then it's given into a stack of registers, okay? That's one register on top of another, okay? So they're stacked up. And then at the end, after you've put all your data in, then you select the operation, okay? You say a plus if you want to add the items in the last two registers that you filled, or you can subtract, okay, you can subtract the second, the last one from the one before, and you can do a number of different mathematical operations to it. You can actually use, ask to do a cosine or a sine of the last item that you entered into a register. That's the way the HP system is worked, okay? Some people swear by the HP system because it seems to be a more logical approach, all right? But most of us are stuck with the TI instrument type, okay, and we can both types can be programmed differently, all right? So today's topic will be mainly shift registers and how do we accomplish that? We accomplish it in one of two ways, okay, or a number of different ways that we can enter the values into these shift registers. So that is what today's topic is all about.